Hey guys, here's the review for Spiral 12. We're going to start off with some applications of exponents and some applications of quadratics and exponent rules. First of all, we've got our applications problem. This is going to make use of some nice quadratic reasoning and a formula from physics that tells us the height of something is equal to -16, that's acceleration due to gravity, times the time squared, plus whatever the initial velocity is, times time, plus the initial height. In this problem, we're looking at trying to launch things from more or less the ground up onto the second floor landing. So we've got to figure out what goes where here. First thing I say is the initial velocity is 40 feet. The second floor landing is 54 feet. That's where I'm trying to end up. So that's up here. That's not how high my projectile is. Okay, I'm going to keep reading. Projectile is launched from a height of 3 feet. Okay, so that's my initial height. So h sub 0 is 3. So we've got h of t is equal to -16 t squared plus v sub 0 is 40 t, and then plus 3. Can a catapult launch the stuffed animals up to the landing? Show your work. Okay, so I've got to figure out if it's possible for my catapult to get up to 54 feet. There are a couple different ways for us to go about this. One of them is to try to solve our equation in terms of setting this up like a quadratic, and an alternative would be to find the maximum height based on this equation and seeing if it goes above 54 feet. Let's take a look at what happens with the first option. So if we've got 54, that should be the height that we reach is -16 t squared plus 40 t plus 3. We should get an answer for this if this gives us something that would make sense. So if I look at this, I don't know this is going to be factorable, so maybe I'll try this by completing the square. And to do that, I'm going to have to divide everything by -16 and bring that 3 over to this side. Do that first. So 51 is equal to -16t squared plus 40t. If I divide everything by -16, I get -51 over 16 is equal to t squared plus 40 over 16t. If I split that up, I get t squared plus 20 over 16t plus 20 over 16t, and that's equal to -51 over 16. I'm going to multiply those two and add that to both sides. So that's plus 400 over 64. Oof. Maybe I should reduce these first. That's going to be 10 over 8, which I can reduce to 5 over 4. Okay, and if I multiply those now, I get 25 over 16. That's much nicer. 25 over 16. So we end up with t squared plus 5 over 4t plus 5 over 4t plus 25 over 16. That's going to be equal to -26 over 16. Still kind of gross. Okay, I'm going to finish completing the square. So we get t plus 5 over 4 squared is equal to -26 over 16. And then when I go to take the square root, I end up getting t plus 5/4, this is really messy today, is equal to the square root of negative 26 over 16. That's an imaginary number. So that would be square root of 26 over 4i. If that's an imaginary number, this solution is not a real number, and that means this cannot go up that high. This point is not going to be something that fits on our graph. In other words, with the imaginary solution, the answer is no, that would not work. As an alternative, I could find a way to do this by finding the maximum. I'm not going to go into that here. Part C, if they wanted the 10th staircase 15 feet high, okay, this is doing the same type of thing. So 15 is equal to negative 16t squared plus 40t plus 3. All right, this one might be factorable. I don't like that negative in front, so I'm going to bring everything over to the 15 side. We get 16t squared minus 40t, and then 15 minus 3 would be 12. Everything here is divisible by 4. Let's make this a little bit easier to work with. 4t squared minus 10t plus 3 is equal to 0. I don't know if this is going to be factorable, so we're looking for things that multiply to 12 and add up to negative 10. 1 and 12, no. 2 and 6, no. 3 and 4, no. Not factorable. We get to complete the square again. I'm going to bring that 3 back to the other side, divide everything by 4. We end up with t squared minus 5 over 2t is equal to negative 3/4. Okay, I'm going to split the 5 over 2 up into minus 5 over 4 and minus 5 over 4, because that's what half of 5 halves is. And I'm going to add to both sides 25 over 16. Hey, that looks kind of familiar. 25 over 16. This one's going to come out much nicer. Give myself a little bit of room. We end up with t minus 5 over 4 squared. I wonder if I lost a negative on the other side. I totally did. But that's okay, because the negative on the right side would have stayed the same. Okay, just checking. If you didn't pay attention to that, that's okay. 3/4 is the same as 12/16, so we end up with 13/16 on the right side. Square root both sides. Add 5/4, we get 5/4 plus or minus the square root of 13 over 4. Okay, and since we're looking for the later of these two, because this is when it's going to be that high going up, and then coming back down, it's going to hit the second time. We're looking for the positive one. That's the one that's going to be later. So the real answer would be t equals 5/4 plus square root of 13 over 4. Ooh, that was a long problem. Moving on to some exponent rules. These will be a little bit shorter for us. We're trying to get rid of some negative exponents, and we've got to deal with some combination of terms here. First one, let's get rid of these exponents outside the parentheses first. That means I'm going to distribute those exponents to each of those powers. A squared b to the 5th over c to the 8th all to the 3rd is going to be a to the 6th. 2 times 3 is 6. B to the 15 over c to the 24. And then for my second one, I'm going to deal with that negative now and flip this while squaring these guys. So the b is going to move up top, and it's going to become b to the 14. A is going to move to the bottom and become a to the 6. All right. It looks to me like my a to the 6's cancel out. b to the 14, b to the 15 times b to the 14 is going to be b to the 29. And on the bottom we've got c to 24. If you had multiplied that negative 2 in, you would have ended up at the same place. You would have ended up with a to the 6, b to the 15, c to the 24 times a to the negative 6 over b to the negative 14. And similarly, when you do a to the 6 times a to the negative 6, you get a to the 0, in other words 1. 15 minus negative 14 is 29. And that c just kind of sits there. For the next one, I'm going to start with my numbers. 144 divided by 84, both those are divisible by 12. That ends up with 12 sevenths. Then I've got x to the 12 divided by x to the negative 4. 12 minus negative 4, that's going to be x to the 16. Y to the negative 6 divided by y to the negative 13 is going to be negative 6 minus negative 13, y to the 7. Z to the negative 2 divided by z to the 11 is going to be z. Negative 2 minus 11 is negative 13. This would be a fine answer except for that negative exponent. I'm going to write this as a single fraction. Positive exponents on top and negative exponents on the bottom. 7z to the 13. Next up, we've got to do some polynomial stuff. I'm going to start off by doing some combination-like terms and some distribution. First one, this is subtraction. This is not distribution. If you find yourself multiplying and getting 9 things, you're probably going down the wrong path, because I'm not going to give you both of these as multiplication. 2x to the third minus negative 16x to the third is going to be 18x to the third. 3x minus x is going to be 2x. Negative 3x squared minus negative 3x squared, those cancel out. And then we'll have the minus 2 sitting at the end of this. When I'm multiplying, then I do have distribution. X squared times 2x squared is 2x to the fourth. X squared times minus 18x is minus 18x to the third. Negative, I forgot one. I'm going to get plus 40x squared. I'll switch colors. I'm going to get negative 2x squared plus 18x minus 40. I'm going to combine some like terms if I can. And oh, look, I have a 40x squared and a minus 2x squared. That's 38x squared. I think those are my only like terms. So 2x to the fourth minus 18x cubed plus 38x squared minus 2x, minus 18x and minus 40 is my final answer there. Sketching a graph of this polynomial, first thing I've got to find are my x-intercepts and y-intercepts. My x-intercepts will be based on what makes each parentheses equal to 0. It's going to be 4. Let's mark that. It's going to be negative 2. Let's mark that. I also noticed that negative 2 has a squared. I'm going to write bounce there. And then this last one is going to be 3 halves. And 3 halves is going to be right in there. And since that's cubed, that's going to be hesitation, slide, or drag is what you guys like to calling that. Okay. The next thing I have to do is get a y-intercept. And my y-intercept is going to be what I get if I plug 0 in. So I've got negative 4 times 2 squared times negative 3 to the third. So that would be positive 4 times 4 is 16. And 16 times negative 27 is a really big number. It's going to end up being 144 times 3 negative, which is going to be 420, 432 negative. So we got y is equal to negative 432. I'll mark that right there. And then the last thing I have to do for this problem is do some nice sketching. I'm going to connect those two first. that guy's a bounce. That guy's going to drag through there and then just shoot down. F of x approaches negative infinity as x approaches negative infinity. That's going to the left. Both are going down. F of x approaches negative infinity as x approaches infinity. That's going down and to the right. Now it's in polynomial division and special factoring. I'm going to start off with something that I have to do with long division because I can't use synthetic division using the rules that we know for an x squared. That makes that a little bit uncomfortable, but it's a doable problem. The other thing that I notice is that we're missing x cubed and x, so I'm going to be careful about where I line things up. It's useful to put in a 0x cubed and a 0x, but if you're careful, you don't necessarily need to do that. Okay, what do I multiply x squared by to get to x to the fourth? That's going to be x squared. When I multiply down, we get x to the fourth, and then minus 2x squared. And because that's x squared, it lines up under the next term. That's why I don't necessarily need to do that placeholding if I'm careful with long division. If this were synthetic, I absolutely need to use a placeholder. Okay, I go to subtract. I get 0, and I get 4x squared. X squared to 4x squared, that's going to be plus 4. When I multiply that down, I'm going to end up with 4x squared and minus 8. When I subtract, I get 0. Yes, it is a factor, and that's because the remainder was 0. Next one. X minus 2 means I can use synthetic division, which I'm going to do because synthetic is way faster. My coefficients, I'm not missing any powers, so 1, negative 2, 4, negative 8. Bring down the 1. Multiply 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 2. 4 plus 0 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. The answer to this would be 0 remainder. 4 is my number. 0x, 1x squared. Is x equals 2 a 0? Well, since x minus 2 is a factor, that means that x equals 2 is a 0. In other words, if I were to plug 0 into this equation, I would get 0 as an answer because if I plug 2 into this equation, 0 should be an answer. 2 minus 2 is 0, and 0 times whatever this ends up being would always be 0. If I didn't remember, I could plug this in, and 2 cubed minus 2 times 2 squared plus 4 times 2 minus 8 would also be 0. And you can verify that if you'd like. Now we got to do some factoring. Something cubic, my first instinct really should be to try to factor this by grouping. That's going to be our fastest and best way to do this. First two, I have an x squared in common. And I'm left with x plus 2. Second two, I can take a minus 9 out, and I'm left with x plus 2. Whew, by the hammer of Thor, that worked. Now I can factor out an x plus 2. And that leaves me with x squared minus 9. X squared minus 9 is going to be a difference of squares. So I can treat that as factorable and go one step further to get x minus 3 and x plus 3. At this point in the year, it's important to begin recognizing difference of squares as factoring patterns. In fact, I'm going to use my psychicness to predict that we're probably going to have to use that for this one as well. Okay, this one is quadratic-like. We got x to the fourth and then an x squared and then a number. My powers are decreasing by a factor of 2, and that indicates to us that we're probably looking at quadratic-like. So I'm going to look for things that multiply to a times b is going to be negative 64x to the fourth, a times c, sorry, and I'm going to try to add up to 12x to the fourth. Okay, things that multiply to 64. It's going to be negative 1x squared And positive 64x squared, no. Negative 2x squared and positive 32x squared. Nope, 3 doesn't work. 4, negative 4x squared and positive 16x squared. Hey, that adds up to 12. That's a winner. So x to the fourth minus 4x squared plus 16x squared minus 64. I'm going to factor this by grouping. The first two have an x squared in common and leave me with x squared minus 4. The second two, I can take a 16 out. And that's going to be plus 16. And I end up with x squared minus 4. So that's going to be x squared minus 4 and x squared plus 16. That first one is difference of two squares. That's x plus 2. X minus 2. I told you my psychicking was totally on. We got x squared plus 16 as my other factor. That is not traditionally factorable. This answer is done. If you're curious why you can factor that first guy but not the second guy, then pay attention for the next 30 seconds or so. Otherwise, tune out or skip ahead. If you really want to think about this guy as difference of squares, what's really happening here is this is going to be, I'm going to keep my x plus 2 and x minus 2. The sum of squares ends up with a pattern of x plus 4i and x minus 4i. Because this could be written as minus negative 16, and if you treat negative 16 as a perfect square, it's going to be 4i and negative 4i. You don't need to do that. That is going far beyond what's necessary for this problem. But if you'd like to, that's where that would come in. I'm going to highlight that in black so that if you're looking at this at the end, it's a little bit harder for us to see because we don't need that information. Do not do that. And finally, we're looking at the rational root theorem. We're given a couple problems, and we've got to try to factor them. First one up, we've got x cubed plus 3x squared minus 4x minus 12. I can't give you that complex of a problem just because that takes forever. So we're going to start with something that's only cubic. So A, possible rational roots. For factors of negative 12 divided by factors of 1. So that's plus or minus 12, plus or minus 1. It's going to be 6 and 2 next, plus or minus 6, plus or minus 2. And then it's going to be 3 and 4. So plus or minus 3, plus or minus 4. Since 1 is only divisible by 1, I don't have any other factors. That's going to be different for problem number 9, where I will have some other ones to do. B, completely factor. Okay, because this is cubic, the first thing I want to check is to see if this thing is factorable by grouping, because if it is, I save myself a lot of hassle. If it's not, then I have to use some other methods. I can take an x squared out, and I've got x plus 3. I take a minus 4 out, and I've got x plus 3. Woof! That is factorable by grouping. So we get x squared minus 4 and x plus 3. I can go one step further, and that difference of squares, x squared minus 4 turns into x minus 2, x plus 2. And we got the x plus 3 sitting there. Again, if you can factor by grouping, factor by grouping. It's much easier, and it's faster. Last part is C. We're going to find all the roots of f of x. So the roots are going to be x equals 2. That would make the first piece 0. X equals negative 2. That would make the second piece 0. And x equals negative 3. That would make the third piece 0. Number 9, we're going to take a look at this again. A, we're going to find the possible rational roots. It's going to be factors of 15 divided by factors of 2. So we've got plus or minus 1, plus or minus 15. 2 doesn't work. 3 is plus or minus 3, and plus or minus 5. Those are all divided by 1, but that's 1 times 2. So you've also got to have plus or minus 1 over 2, plus or minus 15 over 2, plus or minus 3 over 2, and plus or minus 5 over 2. I've got to consider those. I tend to not look at those first, but if I need to, they're there. Okay, part B, I'm going to try first to do this by grouping. So 2x cubed minus 3x squared minus 32x minus 15. First two, x squared, and we've got 2x minus 3. Second two, I can only take a minus 1 out, and we've got 32x minus 15. Oh, knuckles. That totally does not end up groupable. So I've got to use some synthetic division to do this. Looking at this, I'm probably not going to start with 1. I'm probably going to start with my 3's because it's a pretty small number, but it'll begin to reduce this a little bit faster if I get something to work. So let's take a look at that. Maybe 3, 2, negative 3, minus 32, and negative 15. If I'm putting 3 out front, that really means I'm dividing by x minus 3. Okay, bring the 2 down. 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 32 plus 9 is negative 21. 3 times negative 21 is negative 63. And that does not equal 0. So that is not a factor. Okay, maybe negative 3 would work better. So 2, negative 3, negative 32, negative 15. And in looking at this, bring the 2 down. Negative 3 times 2 is negative 6. Negative 3 plus negative 6 is negative 9. And I'm getting negative 27, positive 27. Negative 32 plus negative 27 is going to be negative 5. Okay, negative 3 times negative 5 is 15. Oh, phew! That gave me something that I was looking for. Okay, so x plus 3 is a factor. As of right now, our factored polynomial looks like x plus 3, and this is going to be 2x squared minus 9x minus 5. And by golly, that looks factorable. I'm not going to factor with division anymore. Now I'm going to factor this as a quadratic. So a times c would be looking for things that are multiplied in negative 10 x squared and add up to negative 9x. That's going to be negative 10 and positive 1. Okay, I'm going to keep that x plus 3 just sitting out front there. And then inside this lovely mess of a parentheses, it's going to be 2x squared minus 10x plus 1x minus 5. All right, first part, I can factor a 2x squared out, or I'm sorry, just a 2x out. I get x minus 5. Second part, I can take a 1 out and I get x minus 5. So we get x plus 3, x minus 5, and 2x plus 1. That is my fully factored polynomial. Finally, we are looking for some zeros. That's going to be x equals negative 3. That's what makes my first parenthesis 0. X equals 5 makes my second parenthesis 0. And x equals negative 1/2. That's what makes that third parenthesis equal to 0.